Hello everyone, today I'm working on an Iceomatic ice machine, and as you can see we have a quick red flash. Alright, so if we pull up our error log here, power LED quick flashed red. Unit has experienced max freeze, 1 hour, or maxed harvest, or both. This is a fully loaded error here. It can be tons of things. So let's just go fire up the unit and let's see what it's doing. Alright, so fire up the machine here. Water reservoir filled, that's good, but that was not our error code. As you can see, the machine is actually not insanely dirty. It is a little bit dirty, but not what we're used to seeing on these Iceomatics. So after 7 or 8 minutes, look what I'm finding here. So this fan is stopping, and then it's going. Okay, and it's doing this consistently. Okay, so what this is telling me is obviously this is going to give a long freeze time. Now it is okay for the fan to stop because we're on a fan switch, but the way it's stopping here, it's kind of stopping halfway through. That's telling me we're having a voltage drop issue or the fan is dropping out altogether. And as you can see now, it is stopped completely and our head pressure is getting high. So let's go ahead and pull up a schematic here. Alright, so let's take a look to see how our fan cycle control works. So it closes on a pressure rise at 250 and opens at 200 psi. So what that means is when we get below 200 psi, the fan should shut off, and then it waits to get to 250 to turn back on. Now this is happening so quickly that I'm pretty confident we can rule that out. We obviously want to be thorough in our troubleshooting, but I don't think the issue is going to be here. So let's go over to the schematic. Alright, so because it's happening so intermittently, we need to make sure we have all our ducks in a row. We need to know what test points we need to test, and we need to test them very quickly. Because this took about 7 or 8 minutes for it to fail. So I need to make sure I'm testing my points very quickly. So what we're going to do is pull up our schematic. First things first, let's pull up our load. And then let's draw out our schematic. So one side is a straight shot from our contactor coil. So is it possible that this contactor's bad and not engaging? Well, if we look at the schematic, we're actually on the line side or the neutral side of the schematic, so we can rule out the contactor, okay? And now let's go to our L1 side, which comes through here, and it comes through a fan cycle switch. Let's just blow this up. So this switch will be open when we're below 200 psi. Once we get above 200 psi, the switch will close until we get to 250 psi. So is it possible that we are getting to 250 and is dropping down to 200 and the fan's restarting that quickly? Not very likely. Okay, and then let's just finish drawing out our schematic. It's coming up here, through here, to here, and we're coming to the board. Could we have a potential board problem? It is possible. We're not going to rule anything like that out. But what I am looking for when the fan fails is I'm going to have 2 test points, okay? I'm going to test potential difference on here. So if I come from here to here, okay, if I have 0 volts across here and voltage coming in, which would tell me that the board is in fact sending voltage, 0 volts tells me that this fan cycle switch is good, okay? If I have 120 volts across this fan cycle switch, it's telling me the fan cycle switch is good if the head pressure is low. So in this case, I know the head pressure is not getting high. And then the last thing we're going to test is power at this motor, okay? So if this motor is receiving 120 volts and is not working, obviously the motor is the problem. So I'm leaning towards either A or B, the motor or the fan cycle switch. Let's see if we can test it. In this case, the problem is very intermittent, so I need to be very quick with my testing. Alright, so I finally got the fan to fail again. I had to wait an entire cycle. So I'm checking for power into our fan cutout switch. Alright, so because this is an intermittent problem, I had to wait an entire cycle. So I just wasted 17 minutes there. It is what it is. We have all our ducks in a row. So first thing I'm doing is I'm checking for voltage right here. And we had 120 volts. And what does that tell me? It's telling me if we have power at this point, guess what? Our board is doing its job, okay? So I can now rule out the board. The next thing we want to check is potential difference right here. Let's go across this switch. Let's see what voltage we get. So as you can see here, I'm testing potential difference. I'm checking across the switch, and this part's a little bit tricky to film, but we have 122 volts across. All right, so we had 120 volts across on potential difference. So that tells us this switch is open. The only time this switch should be open is if we are below 200 PSI. As you can see here, our head pressure is 235 PSI. That switch should be closed. All right, so I did go ahead and replace that faulty fan switch. Now you have two options. You can recover the refrigerant and replace the switch, or you can pinch off and replace the switch. Now I know Manitowoc under warranty recommend that you pinch off and replace, just for the fact that it saves them on their labor charges, and it is what it is. So do whatever your company requires you to do. As you can see here, we're in a harvest cycle, 17 minutes, dropping ice. We will do a thorough cleaning, and we are good to go here.